Hello, hi everyone. Welcome to this session. So today I'm going to present one more solution, which is another cloud project with AWS, and I have integrated a couple of more tools from AWS and even Ansible and Terraform as well. So uh, this is the project high level overview. Let me just go through. So if you see, the project is AWS EBS root volume disaster recovery monitoring and notification. So basically this project I am going to deploy along with this monitoring and notification solutions, and I have integrated Terraform and Ansible as well in this project. So in order to automate automated way provisioning the AWS resources web server, and Ansible I have integrated in order to create a snapshot automated way. So that is the high level project overview of this project. So I would like to go through all these details. Even I have created the detailed documentation as well, and I am going to do hands-on way in this session, entire end-to-end scenario. Even we will simulate the disaster recovery, uh, through which we will uh, uh, be recovering this web server, and within the given time period. So I have tried to incorporate the RTO and RPO requirements as well, so through which we will discuss, and I will go through this project, and I will do hands-on and show you how it can be done. So that is the agenda of this today's session. So as it can be seen, this is the architecture, high level architecture. I have already mentioned in my documentation as well. So if I show you in a detailed manner, so let me just show you here. Let me minimize a little bit. Okay, so this is the architecture. This is the entire architecture. If you see, as the title already represents itself, what it does, entire architecture. And even I have designed one more architecture in order to explain more concise and clear way about RPO and RTO, and how it is going to be achieved in when the disaster happens in the infrastructure, how it can be recovered, and what could impact, and how we can roll back our through our backup, and again our system is up and running. So that's this RPO and RTO architecture is representing everything about it. I will explain the complete architecture in a detailed manner. Let's just get started from the start of what this entire project is about. So I already mentioned the project. Again, it is based on AWS EBS root volume disaster recovery, monitoring and notification. So the web application which we are going to deploy and recover is the full web portfolio application. Actually, this is my web portfolio application, which is in HTML, PHP, and somewhat JavaScript. So this web page I will be deploying through the Terraform into the AWS cloud. So the cloud services which we are going to use this is to AWS EBS volume snapshot CloudWatch and SNS, and we will deploy one of the Apache web server inside the EC2 machine. So this is the small description of this project. So basically company got a requirement that has to prepare for disaster recovery scenario, and has to implement the monitoring and notification solution as well when actual disaster is happens, how the entire system is going to be recovered. So that is that's I just little bit mentioned over here. This is about RTO and RPO requirements. So in order to maintain the business continuity requirement perspective, here the RTO is defined 10 minutes and it must meet the downtime and acceptable in order to recover the system from the failure. There is RPO, which is 5 minutes. It must meet this, and system should be able to get back and recover the backup within the last 5 minutes. So RTO stands for recovery time objective, and RPO stands for recovery point objective. So as it can be seen, the table, it is also described in order to explain you better. This project demonstrates the experience of designing, implementing, and disaster recovery scenario which can fulfill the defined business RPO and RTO requirements, along with the CloudWatch monitoring and SNS notification system. So tools and technologies covered again: AWS Cloud, IAM module, EC2 module, CloudWatch, SNS. I have covered Terraform, Visual Studio Code, GitHub, GitBash, Show.io, even Ansible. I just forgot to mention here. These are the tools. So let's just discuss little bit about RPO and RTO and RPO. So what AWS offers actually 4 levels of disaster recovery support across a spectrum of complexity and time. So if you see, there is a 4 type of DR support system based on the requirements. So one is backup and restore, second is pilot light, third is warm standby in AWS, and hot standby with multi-site. Each one has its pros and cons, and for cost perspective as well, it goes from low to higher cost. So if your RPO and RTO requirement is in hours, then the cost is very low. Based on your priority use case, the cost will be low. If your RPO RTO is within like 10 minutes of timeline, then it will cost a little bit. Then if your RPO RTO in minutes, then even less than 10 minutes, then it will cost a little bit more. And if your RPO RTO is in real time, then your cost is way high. So there will be auto failover of your entire environment is already been deployed and in another region or another site, and it might be parallelly running. So only thing is when the disaster happens, it will just trigger to the second zone and DNS, and it will work from there. So that way the cost is obviously high, because both the things will be parallelly running in another site. These are the resilience resources I have referred from the AWS. So what are the features Amazon EC2 offers in order to maintain data resiliency and DR? So copying AMIs across regions, you can copying EBS snapshots across regions, automating EBS bet EMIs using Amazon Data Lifecycle Manager. You can automating EBS snapshots using Data Lifecycle Manager, maintaining the health and availability of your fleet using EC2 auto scaling, distributing incoming traffic across multiple instances and single artist zone and multiple AZs using elastic load balancing. So those are the data resiliency features and checkpoints through which you can achieve the RPO and RTOs, and disaster, you can avoid the disaster recovery. And let's discuss the instance status checks, which we are actually going to utilize in today's session, and we will simulate the failure using the instance status checkpoints, and then we will recover from that, and our system will be up and running. So there are many instance status checks are there: failed system status checks, incorrect networking or startup config, exhausted memory, corrupted file system, incompatible kernel, and those are the things which can be considered inside the instance status checks. And we will be simulating one of them, and we will even configure the CloudWatch and SNS, through which we'll get the notification that your instance status check is failed, and you need to recover from that from your past configuration or past backup. Okay. So now let's discuss this solution architecture which I have designed and created. So this is about a whole picture of the today's hands-on session, what we are going to achieve in this hands-on, and how it is going to achieve what this all entire architecture is represents. So I am just going to uh, explain entire thing in a little bit clear manner. So as it can be seen, this is the AWS cloud space, entire AWS cloud space. This is the local environment again, and this is the cloud engineer sitting on the other side, on the left side. And cloud engineer is responsible for maintaining, deploying the resources, provisioning the resources, configuring, and maintaining the disaster recovery and everything. So the cloud engineer, if you see, let me just give you the overview of this. What three signals are here? So this denotes the normal flow. This denotes the system is under disaster uh, situation where the disaster is triggered, and this denotes the system is going to be recovered or recover from the disaster recoveries, these green ones. So if you see in the entire infrastructure diagram, these are the lines, dotted lines, and these things are I have separated out in order to convey the message clearly so users can easily understand and identify what it does mean. Okay. So let's start from here. As cloud engineer is here, he's just working inside the Studio Code IDE, where he has configured the AWS and writing the Terraform scripts for this web project, where main.tf file, variable.tf, output.tf file has written within this VS Code. So if you see, we are just discussing the normal flow first, which is here. So n1 to n2, and the Terraform file is written, and It will just initiate the Terraform, but you through the Terraform init, then Terraform plan, this N3, it will apply the Terraform through the command Terraform apply. So all those resources will be provisioned inside the AWS here through this apply command. So N4 is EC2 machine is configured, provision here, and inside that EC2 machine there is a small script I have integrated, which is a user data script, which is responsible for installing and configuring the Apache web server and configuring the web source code project, which is my portfolio application. So this is web server. It will be configured by the time in Terraform will provision the resources. So then if you see here, NAND5 will go here, this line, then user will be trying to access from the web browser the website http www.profullcloud.com. So user will be successfully access this website in a normal workflow. Okay, now let's go to the monitoring flow. So here if you see, I have configured the Amazon Cloud Watch, where I will pick up one of the EC2 metric predefined status check metric, which is status check failed underscore system metric. I will select that one, and I will create one of the alarm within the Cloud Watch. I will configure all those threshold and everything, and then I will also create one of the SNS topic. It will be notified through the configured email address. Whenever the system check is failed, it will notify through this email notification, and this email notification will go to this cloud engineer. Okay, so that's I will show you as well in the hands-on. Now let's go to the disaster trigger flow, which is here, denotes in red zone. So if you see here RTO and RPO, I have mentioned in this table as well in order to clearly understand within the infrastructure. RTO is 10 minutes and RPO is 5 minutes. Okay, again one more thing is left to discuss even in the normal flow. So in the normal flow, when the EC2 machine is there, if you see this N7, it has like Amazon Elastic Block Storage is attached, and which consists like volume, root volume. So if you see here, root volume A default is attached, which is N8, and once it is done, we will create a snapshot of this actual volume, root volume. So we can even take a snapshot either manual way, and either we can automated way. Here I will be taking through the Ansible automated way. So if you see here, it will take the snapshot of this volume A to N9, if you see here. Okay, so that's where our normal workflow is complete, and now we are going to discuss the disaster trigger flow. So let's say there is a disaster happens and your entire root volume is got corrupted here. Okay, this is your root volume, and if you see here, DRT1 is triggered, disaster is triggered, and it goes here, your root disk is corrupted and got cancelled or not responding. And if you see here, it is attached through the EBS DRT2. It the disk can be failed in many such reasons, like some wrong patching happened, or some files removed, packages removed from the Linux, or some volume got corrupted. So that may be the possibility. So let's assume it got corrupted here, and um, it is not responding. So okay, so in that case, the system status check will be failed. Assume that. So in that case, if you see this DRT3, it will go to the EC2, and to the EC2, it goes to the DRT4 web server, DRT4 to the DRT5, where the users are going to access our web application. Okay, during the disaster triggers scenario. So in that case, user won't be able to access our web application. The web page is not available, okay, because this disaster has already been triggered due to our instance root volume got failed. Okay, and with that, system has notified to the cloud engineer that system check monitor fail metric has notified to the cloud engineer that you got this failure. Okay, and now cloud engineer has come into the picture and try to identifying the issues and what could cause. So already system has notified what could be the where the root cause has happened, so it will just go straight away, and our through our snapshot mechanism we have already backup of our root volume. Okay, so now this disaster has already happened, and we need to recover entire system within 10 minutes after disaster has triggered. Okay, so we have only 10 minutes, and during that 10 minutes our system is already down, and during that 10 minutes period we need to backup install the backup back to the EC2 machine, and we need to back our system up and running. So in that case, we have already taken the snapshot of our root volume. So now we are going to discuss this, how we are going to recover from the disaster. So this is denoted in the green. So in the green. Okay. So if you see here, we are going to just recover. So system cloud engineer is going to see this snapshot that already been taken, and they are in complete state. So it will take this snapshot. So this is the RPO. Okay, so RPO means recovery point objective, and we need to meet in 5 minutes. Okay, so RPO, it means like we need to go back into last 5 minutes of last backup, data backup. So how far we should go back in order to take the backup of that system. So let's say we have multiple backups available, like 1 hour backup, minutes backup, like we have backup available of 5 within the 5 minutes. So system is so critical, then there might be chances that system may be configured that it is taking frequently backup. Maybe that can be possible. So we have backup of last 5 minutes in terms of snapshot available here. Okay, so now we are going to just restore this backup through this RPO. We have already last 5 minute backup. I will just go here through DRR2. If you see here, I will go to the EC2 machine root troubleshoot and monitoring section, and I will attach this snapshot straight away to this EC2 machine. EC2 machine is still in running condition, and I will attach this snapshot to this machine. And if you see, now the RTO comes into the picture, which is 10 minutes. So RTO is a recovery time objective, and we need to recover within the 10 minutes. We have downtime of 10 minutes, and we need to back our system up and running within the 10 minutes. Okay, we don't have much time. system is critical and we need to have our system up and running as soon as possible within the 10 minutes. Okay, so uh, we have already attached our snapshot to this EC2 machine, and if you see here DRR3 is there, and new volume is created by this snapshot automatically. If you see inside the elastic block store volume section, the snapshot you have attached to the EC2 machine, the new volume has already been attached and it is in use now, in use status now, and the older one which got corrupted, it will be in available status now. Okay, it is no more use. So now it is attached, and let's see with this flow DRR4, it goes here inside the EC2 machine to the web server, and our users are trying to access the web application again, still trying to access, and through the DRR5 flow and DRR6 workflow, users will get the application up and running. So we have achieved our RTO and RPO within the 10 minutes of period. We achieved the RTO and we achieved the RPO within the 5 minutes of time period. Okay, and now our system is up and running, and user is successfully able to access this fullcloud.com web application. So that's how we have achieved this entire disaster recovery scenario in real-time manner. So this is everything about this solution architecture. I will be just showing hands-on as well right after this explanation. Let's discuss one more architecture, which is RTO and RPO, in order to explain in more concise manner so you can have more understanding about RTO and RPO. So guys, if you see here in the RPO and RTO diagram, the left direction is going towards the recovery point objective, which is our RPO, and the right direction is going towards the RTO, recovery time objective. And if you see here, our scenario is we need to have 10 minutes RTO and 5 minutes RPO. Okay, this is the point, recovery point. And this is the disaster triggers here. Okay, disaster. Okay, so again, this is our web application up and running. This is our web application which is inaccessible, not accessible due to the disaster. So if you see here, when disaster triggers here, we have downtime of this 10 minutes towards the RTO. Okay, towards the RTO. So we have only 10 minutes to recover from the failure, which is called RTO. Okay, which is here 10 minutes. Okay, and here as well I have mentioned in the table. And we have our RPO, which is 5 minutes here from the downtime disaster triggered. Okay, so that means the data lost can be within 5 minutes. How much data lost can be affordable by the business, in that is what mentioned inside the RPO. So in RPO, it means only 5 minutes of data can be affordable by losing by the system, by the business. Okay, and we will have backup of last uh, previous time last backup. We will restore that backup and we will have only lost of 5 minutes. Okay, 5 minutes, last 5 minute transactions will be lost, but we will be recovered from the previous transactions due to through our uh, recovery point. Okay, so again let's assume the disaster trigger here. If you see here again is disaster trigger and disaster recovered. So if you see here, disaster is triggered, hard disk is failed, status check failed, and web application is not available now. Okay, and now we have only 10 minutes of recovery time, 5 minutes of recovery point RPO, and now we have our snapshot available, previous snapshot, so through which during the downtime of 10 minutes through this snapshot we will restore this snapshot and the volume will be created again itself, and the root volume will be again working, functioning correctly, and then user will be able to access this web application function correctly again. The system will be up and running. Okay, so that is what everything about the RPO and RTO. So as much as less RTO RPO within seconds, it will cost higher, and it's more than seconds, like greater than more than seconds in minutes, hours, days and weeks, it will cost low. Okay, so if you see here, you can definitely summarize this. You can conclude this everything whatever I have said and mentioned here through this diagram. I have tried to explain you in a concise manner how we can recover when the disaster is triggered. Okay, I will show you that hands-on way uh, right after this discussion. Okay, so this is the entire documentation. I have created everything phase by phase, so you can implement yourself as well. I have tried to put everything in a sequential manner. Okay, my GitHub repo is already given in the documentation, so you can definitely go there and check and do by yourself. Okay, so let's now just go step by step and implement this entire architecture. Okay, so just I'm going to my console. This is my VS code actually. I have inside my working directory. This is my project where all those necessary files are present there. I will just let me just go to the AWS console. So guys, as it can be seen, we are inside our Amazon console, AWS console. Let's see, there is no any instance is running. This is already been terminated. So now let's just go to the VS code and just deploy on the web application which we are going to simulate towards the disaster recovery. So this is my Terraform project directory, as I already mentioned. So now just let's go and deploy the web server using the Terraform. So I will just check first Terraform init. It will initialize all the necessary plugins for Terraform. I will do the Terraform plan as well in order to check if any discrepancies are there. So I will show you three scripts as well in this project. One is Terraform, second is I will show you the shell script to remove the web server project directories and files in order to simulate the disaster recovery. I will also show you the Ansible scripts to take a snapshot of the volume, and I will also show you how to trigger the CloudWatch alarm, how we can simulate. That's the thing. So let's just apply. Everything is good. So I will just hit Terraform apply auto remove auto apply. It will not ask. um, Sorry, auto provision. I am doing some mistake. It's supposed to be auto approve. Okay, it works, and it will be auto deployed without asking the user permission. So as I mentioned, we will do this way. If you see here, I will already init the Terraform. We already apply that. Okay, so these are the step-by-step sequential snapshots. I have mentioned everything. Once it is applied, it will look like this. We will get our Terraform output of instance ID, public IP, through which we can access from the web browser or a web application. Okay. See, it is going to be created. It has already started creating, provisioning the infrastructure. If you just need to see, these are the main Terraform files. If you just have to look it, these are the output file, and this is my user data script actually, which through which my web application will be installed automated way. Even Apache web server will be automated way installed, configured the directory and everything. And through here my source code web application will be installed and within the Apache root directory. See. So yeah, it has provisioned the infrastructure successfully. This is the public IP through which we can access our web application from the browser. So now let's just verify from the console if the web server is up. Yeah, here it is. Our web server is up. Just hit on the browser. The application is taking some time to configure. As I just told, these are the things. The user data script will install this all the packages inside the EC2 machine. This HTTPD package, MariaDB package, and even it will fetch this source code from the Git and it will copy it inside this HTML directory. So this can take some time, first time actually. This is the public IP. We have right public IP actually. Yeah, here it is. Our web application is up and running now. If you see, this is my web portfolio application. This is about me, my certifications. This all sections works. Okay, so this is the web application which we are going to simulate through the disaster recovery scenarios, and I will show you how we can recover from that. Okay, so let's just go to the document part. We were here. We are successfully able to access our web application. Okay, now the phase 2 is take a snapshot of the root volume. Okay, we need to take a snapshot of our root volume. We can take either manual way or either automation Ansible way. I will show you Ansible way. This is the 2.1 Ansible automated way. Let's just observe the volume first. So if you see, this is the current volume, root volume, which EC2 has attached, and it is in use state right now in 1F. Okay, this is the volume ID, and let's check snapshots. There is no any snapshots right now, and we will just go and take a snapshot through the Ansible. Okay, so to take a snapshot we need to gather some facts, but right now I need to gather the facts manual way. Due to lack of time, I didn't put that effort to come to completely automated way. So this is my playbooks here. This is under a task. There is a EC2 snapshot YAML file. So I need to gather first of all if region is right. I think if you go inside U East 1, it is correct. So we need instance. This instance ID I will provide here. Okay, this is all good. DevX VDA, where it is connected. It is connected here, so it is all good. Nothing need to be changed. Okay, just change the dates actually. also all good. Now, before running this playbook, I would like to show in the console there is no snapshots, any snapshots available. Okay, no. And let's go to the architecture. So in the architecture we are here. Actually we already done this part, normal flow. We are here just going to take the snapshot through the Ansible. So it will take the Ansible will take the snapshot of root volume A and store inside the snapshot. Okay, so there is nothing here snapshot. Let's just go to the IDE. This is my playbook.yaml main YAML file. I will just run inside. First of all, let's go to the playbook folder. Just run the playbook. Okay, this is the command through which I will hit the Ansible and it will run the playbook of taking the snapshot. Okay, so yeah, it has just started. Read the EC2 instance and take the volume snapshot. See, it has already started. It will take a few seconds to come up here. Yeah, snapshot is there. See, if you see the description, even exact description we provided inside the YAML. It is still in the pending status. When it is in complete status, we will move forward and then Ansible playbook will stop. So this is the description. Let me just show you. See, snapshot of web server data taken 22/6. See, this is the name, snapshot ID. Let me just open my one of my email IDs, so where we need to configure the SNS topic. Let's just check the status of Ansible and the playbook. It is still in pending status, unavailable. Takes a little while. So let's just move here in the documentation part. So this is the snapshot.yaml through which we are taking a snapshot of our EBS root volume. Once it is done, it will look like this. Then we will go and verify that snapshot is in completed status. Then we will move forward to the next phase, which is about config CloudWatch monitoring and SNS topic for failure notification. Okay, yeah, here it is. We are in OK2 status. That means let's just see here. The snapshot is completed. Okay, there is still one main root volume. There is no any additional volume. Okay, only snapshot is taken right now. Now let's just move forward to the CloudWatch monitoring part. Okay, so I will go to right away. I will go to the alarm section. Under the alarms, I will create an alarm. I will select the metric. I will go to the EC2 for instance matrix. I will find our current instance is this web server. Okay, we need to find the status check failed metric. Here it is. First, status check failed underscore system. Okay, here it is. Just select that one. Okay, we have already selected this metric. Select. Here it is, metric name, instance ID, average nothing, period I will do 1 minute, threshold I will do greater or equal to 80, and the additional configuration data points to alarm. Two out of 1 would be failure, then notify. In alarms, when this alarm will trigger, it will be in alarm status, and when it will be normal, it would be in OK status. Okay, so select an existing SN. No, we need to create new topic. So default CloudWatch alarm topic is fine. No, let's just give our web server. Okay, my email. I will just click create. It will create the SNS topic. Later we will go inside SNS topic and we will configure. Then EC2 action. What type of EC2 action we need to be taken? So I will do like I need to recover this instance. Okay. You can stop the instance, terminate this instance, reboot the instance, but I would select the recover this instance because we need to simulate here. Okay, click next. Alarm name, create alarm. Our alarm is created. It will be in OK status soon. Now it has no sufficient data right now. Okay, so now let's just go to the SNS. because we need to confirm the subscription. Go to topic. Here our topic we just created. Click pending confirmation. I will check that email because I might have already gotten. Yeah, see, I have already got this subscription topic. Just confirm from here. Yeah, it is confirmed. See, now just go to here, just refresh, and it will be, yeah, see, this is in confirmed status, this email endpoint. So SNS topic is already been confirmed. Now you will get that email from of the failure. Okay, so now what we need to do, here it is also web server alarm is okay. When it will be triggered due to the failure, it will be in alarm status here. Keep it in mind, it will change the status. Okay, and we will simulate that. Okay, so just go to the documentation. We already configured this one. This is all done. Okay, this is done. We're done. Now we need to simulate and trigger a disaster recovery scenario. Okay, so how it can be done? So here, instance status, hardware failure or system failure, it will be really hard to simulate in real time. Actually, it's easy in real time whenever it does happen, but it's really hard to hear and simulate in this POC environment. So I have found another middle way through which we will just notify to the cloud engineer through the email that your system is in failure status, your instance status check is failed. So in order to do that, we need to do some configuration. Okay, so first of all, let's just log in to this machine, EC2 machine, your web server. Just grab the public IP, go to this, I'm inside the EC2 machine web server. Okay, now let's just become a root user and go to this documentation. Okay, now write a script to remove an application files from the Apache root directory. So need to write a script which will remove the application files, web application file, from this root directory, so we can trigger a system towards the failure. Okay, this is just simulation. Okay, so if you see here, I have already created this script here. Okay, I will just copy this, go to inside, I have pasted here. Saved. Let's just give a permission to execute. this file. Now it has permission to execute. Now let's just see what we are going to do. Okay, so if you see, this is my web application. It is still up and running, our web application. I need to interrupt or remove this application so that it can trigger that our system is failure, your web application is failure, user is unable to access your web application, and it will trigger to the cloud engineer that, and then you need to restore the backup, and then this web application will be backed up again, run from the snapshot backup. Okay, so my files are here. Let me just go. See, this is my index.html file through which this web application is running. Okay, and this is all another necessary folders and every other things which has included everything, programs and everything. So this program I am going to remove, then my web application won't be able to access by the user. So that means from my root volume, these files are corrupted and removed somehow, and my application got crashed or corrupted or inaccessible. Okay, so that is what I am going to simulate. But before that, let me do one more configuration, because we need to simulate the trigger as well, CloudWatch monitoring trigger. Okay, so in order to do that, I need to configure AWS configure first. So I have that test user already been created. Raise the access key. This is the secret key. Default region US East 1. All is fine. And now we also need to do one more thing. Need to have that script. Actually, it is here as well. CloudWatch alarm trigger script. Okay, and I need to provide the correct alarm name. So what is our alarm name here inside the CloudWatch? Oh, web server underscore alarm. Okay, alarm name web server underscore alarm. If you see history, there is no anything right now except okay. Okay, so let's just go to here. This is all correct. So this is just CloudWatch alarm triggering script, because we are just simulating we are just pushing the CloudWatch that your system is failed and need to send a notification. Okay, because instance system or hardware failure is impossible to do from in test environment. Okay, so that's why we are just pushing here. So what will be the reason? So simulate that hardware failure, no, software failure. Okay, this will be the message inside the email. but this will we do after removing our web application source code. Okay, we will do that after that, but we just configure now. So as soon as our file is removed, we will do that trigger. Okay, so now let's just move. I just need to run that script which we just created. So app remove. Okay, just see here, pay attention. My web application is still up and running. I just refreshed. Okay, now I'm just going hitting this script and removing the source code. Okay, then we won't have that source code in the root file volume. See, it has removed everything. Files and folder removed successfully from read to directory. See, this was the message where I had given. See, in this script file. Let's just go inside and check. See, there is no any files and there should be no web application running. Let's just go. See, application has gone. No more. Proful's web portfolio is no more accessible. It has completely gone. So assume disaster has already triggered and it has happened. Okay, and we need to recover from this disaster and we need to back that Proful's web portfolio application up and running here again. So what we need to do? So again, let's just now trigger the CloudWatch. Okay, so just grab that script, where it is inside the readme. Okay, as soon as I hit, I will get notified. Let's just verify the email first. See, there is no anything right now, but it will soon. And even here, if you see under the CloudWatch, it will be in alarm status right now soon. As soon as I hit this script, let's just hit. Yeah, it has successful. Just refresh here. Okay, you are in alarm situation. You get a notification. See, new notification, AWS notification, alarm, web server, alarm name, OK to alarm, simulate in an EC2 software failure. See, reason, simulate an EC2 software failure. This is what, see. So Cloud Engineer has received a notification now and it's time to take action to recover from the disaster. Okay. Now let's just jump here right away. Just go once to this. We are under this disaster situation now. Hard volume got failed web application is inaccessible, web page is not available. Okay, we are in this situation right now, and we need to recover from this situation right now back to normal. Okay, so we have only 10 minutes and we need to recover. How we are going to recover? Okay, so that's what I'm going to show you right now. So we have our snapshot is already been created, okay, from our root volume. Let's just move immediately to the instance. Select the instance, go to the action, monitor and troubleshoot, replace root volume. And here if you search, do you see snapshot of web server data taken? This was our latest snapshot. I'm just going to attach here. Create replacement task. It is running. Our web server is still running. Okay, I haven't stopped. Now if you go inside the volume, there will be two volumes. Okay. See, two volumes. So this one is in use. So when we attach, system has automatically grabbed that snapshot volume and attach and did in use state, and the older one is removed automatically and it is in available state now. And that's how I am going to show you with the web server that our web server will be up and running. Okay, so if you see here, we are still, yeah, it is up. Our web application is up and running. We are back to normal now. See, this is how we recover from the failure, from the disaster recovery. See, so let's just see here. What we did, we had a disaster recovery happen here. Here, we weren't able to access the web page application, and due to this root volume from the last snapshot, we immediately recover from this disaster and we were able to access our application again. So that's what we did, and we did within, I think, 1.5 minutes. It's less than 10 minutes even. So that's how we achieved our RTO. Okay. So if you see here, recovery time objective, we already made that, and our web application is up and running again. From snapshot to the root volume restore. We were here when the disaster triggered, and after disaster, we restored the root volume from the snapshot, and we were able to users were able to successfully access this application. So that is what we did and achieve in this entire section. Okay, and now if you go back and see inside the CloudWatch, the system will be OK status. If you see, earlier alarm updated from OK to in alarm when it was failure, and now it is in OK status because everything is normal now. Okay, so actually we didn't notify through the CloudWatch, but we just simulated the integration. Okay, we didn't actually integrate the CloudWatch with the actual failure, but it is about the simulation failure. Okay, so that's what we did here and achieved. So if you see, our web server is still up and running. Okay, our volumes are there. So our current volume is this one. This was just attached from the snapshot. If you see this one. Okay, so with that, I would definitely conclude that we have successfully deployed this project. We have simulated the disaster. We recovered successfully from the disaster. We have already made the RTO, recovery point objective, and recovery time objective. We successfully achieved that, I would say. So if you like to see, we have completed all those sections successfully. I have documented each and everything in a sequential manner. Everything. Even I will post this to the social media on Medium and LinkedIn and everywhere. So you guys can take a benefit from here, there. Okay. Please don't forget to clean up the project, the snapshots, the volumes, whatever you created. Otherwise, you will definitely get the charge after the trial. Okay. So don't left running those volume snapshots. Okay. Just remove that. Even I am also going to destroy this. So let me just go back to the Terraform. I will just destroy. Let's just see the application now first before deleting. See, the application is completely working fine and we successfully recovered from the disaster. Now just let's destroy. Let's just remove the snapshots. Remove the volume. Available volume will be deleted. In use might not. This will be removed by the Terraform. I will destroy this instance by Terraform. So guys, with that, we have successfully implemented this project. Thank you so much. Thanks. I will come back again with new project and challenge by that time. Thank you. Thanks all of you. Bye.